How do stadiums calculate load-bearing for safe concert stages? Imagine a massive crowd gathering in a stadium to enjoy a concert. Behind the scenes, engineers are working tirelessly to ensure that the entire structure remains safe and stable throughout the event. But how do they determine if the stadium can support the weight of the stage, equipment, performers, and audience? The process involves a combination of detailed calculations, material assessments, and adherence to strict safety standards. The first step in calculating load-bearing involves understanding the total weight that the stage and associated equipment will impose on the stadium structure. Engineers start by estimating the weight of the stage itself, which includes the platform, trusses, lighting rigs, sound systems, and any special effects equipment. These components are often modular and can vary in size and weight, so precise measurements are essential. Next, they consider dynamic loads, which are forces generated by movement, vibrations, or shifting equipment during the concert. For example, performers moving across the stage or wind blowing against the structure can create additional stresses. Engineers use data from previous events and simulations to predict these forces accurately. Material strength and structural capacity are critical factors in the calculations. Engineers examine the load-bearing capacity of the stadium's beams, columns, and foundations, referencing detailed specifications and material properties. They perform calculations based on principles of physics and structural engineering, such as static and dynamic load analysis, to ensure that each component can withstand the combined weight and forces. Safety margins are incorporated into these calculations to account for unexpected conditions or errors. Typically, engineers apply safety factors that multiply the calculated loads, often by a factor of 1.5 to 3, depending on the standards and regulations in place. Codes and standards established by organizations such as the American Society of Civil Engineers or local building authorities guide these calculations. These standards specify minimum safety requirements and testing procedures to verify that structures can support designated loads. In some cases, engineers may also conduct physical inspections and utilize load testing on existing structures before the event. This involves applying known weights to certain parts of the stadium to observe how they respond, ensuring that the calculations align with real-world performance. Ultimately, the goal is to ensure that the stadium's structural elements can safely support the combined weight of the stage, equipment, performers, and audience with a sufficient safety margin. This meticulous process helps prevent structural failures and guarantees a safe environment for everyone attending the concert.